So, supermassive black holes are truly colossal objects. So, um, one of the largest, TON 618, has a mass of up to 60 billion solar masses. And so black hole masses will be given in the unit of solar mass. That's equal to approximately 2 times 10 to the 30 kilograms. That's approximately the mass of the sun. Here's a kind of scale comparison of some of the largest supermassive black holes, and this TON 618 is truly gargantuan. For comparison, the supermassive black hole at the Milky Way center, Sagittarius I star, has a mass of approximately a million solar masses, 4 times 10 to the 6 solar masses. And the luminosity of this gargantuan is 4 times 10 to the 40 watts, 140 trillion times that of the sun, again, making it one of the most luminous objects in the known universe. And it has the event horizon has a diameter up to 11 times the radius of our solar system. I see a question that came up. How do you measure the mass of a black hole? The way that this is normally done is that you can see, especially with these supermassive black holes at the center of the galaxy, you can see orbiting stars around the central supermassive black hole, and you can calculate from their orbits and their speed, their velocities, the mass of the central supermassive black hole. So let me see if I can get this video to play. The animation shows 10 supersized black holes that occupy center stage in their host galaxies, including the Milky Way and M87, scaled by the size of their shadows. The shadow of the black hole is thought to be twice the size of the event horizon. So starting near the sun, we're slowly pulling out. The animation shows our own central supermassive black hole at the center of our galaxy, approximately 4.3 million suns. Then we're going to see 2 gargantuan supermassive black holes in GC 7727, located about 1,600 light years apart. One weighs 6 million solar masses, another about approximately 150 million suns. Those will possibly merge in the next 250 million years or so. Then we stop with TON 618 with a solar mass of approximately 60 billion solar masses. And its shadow is so large that a beam of light would take weeks to traverse it. So, we can start to get an idea of the size of these truly colossal objects, these galactic engines. The size and consistency of these supermassive black holes that are coming to light, quite literally, are causing astrophysicists to re-examine and reformulate many ideas about stellar and galaxy evolution. The first issue is that these incredibly large black holes form much too quickly and grow far too large to be accounted for by the traditional model of star death and subsequent accretion of small black holes into larger black holes. For example, 1 billion solar mass black holes have been observed in active galactic nuclei going back to just 690 million years after the so-called Big Bang. And I have discussed this in this article, Astrophysics Gets Turned on Its Head, Black Holes Come First, with Dr. Amir Baker, discussing how now that we're beginning to see at some of the earliest epochs of the universe, when we're looking back 13 billion years almost, one of the things you see is black holes, quasars, supermassive black holes. And, so they're there much too early to be accounted for by the normal kind of conventional model, where black holes are forming due to stellar collapse, collapse of massive stars. So based on the conventional theories of black hole formation and growth via stellar death, this far exceeds that of the expected mass of black holes for that epoch in the universe's development. Supermassive black holes at 690 million years after the Big Bang. Conventionally, black hole masses at this stage in cosmic evolution are calculated to be only a few hundred solar masses, following the previous erroneous models. Note this predicted mass for the first black holes is based on the assumption that these seed black holes are remnants of the first stars, known as population 3 stars, which were formed as a result of the primordial gas cooling when the universe was approximately 200 million years old. However, if black holes preceded the first stars, then they could not have formed from stellar collapse, as the conventional model describes for the formation of most black holes. So, we're getting direct observational evidence of the way that traditional perspective is incorrect, that conventional model. And we're seeing that the black holes were there at the beginning, acting as the seeds of creation. To describe the supermassive black holes that are observable today in almost every galaxy, with masses of millions to billions of solar masses, it is posited that the first black holes grew from direct gravitational collapse of large, extremely large gas nebulae, hydrogen nebulae. However, we also must consider that the energy density of the early universe was extremely high. The amount of energy per unit volume of space in the earliest moments of the Big Bang were of the Planck density. So from this, black holes would directly form. And these are called primordial black holes.